Hello my friends, and welcome back to GZ Codes. On this channel, we are usually working on komorebi, the tiling window manager for Windows, which is written in the Rust programming language. In today's video, we are going to consider the following question. How can we, as software maintainers, fix issues for our end users which we ourselves are not able to reproduce? This has been a bit of a theme with version 0.1.26 of komorebi. There has been a long-standing performance issue that has impacted a small subset of users. I have not been able to reproduce it. A number of people who are quite active on GitHub issues and Discord have not been able to reproduce it, but the evidence is that there are some users who are experiencing this issue. So we're going to start at the beginning. And the beginning is actually not version 0.1.26. We need to go a little bit further back to version 0.1.25. So we're going to do that right here. So we're on the master branch. Let me just make sure I'm up to date. And we're going to check out version 0.1.25. Going all the way back in time. Oh my god, most of these things don't even exist anymore. Or yet. They don't exist yet. So, all the way back in version 0.1.25, we had active window borders, but they were literally only for the active window. So we had border.rs, and in here we had the struct border. And there was only ever one border window. And that border window would be moved depending on what the active window was. So if so here we have like the latest version running, we have multiple window borders, but before we would only have a single window border, right? And it would only be shown on the currently focused window. And so how did that look when we started this up? I'm not even sure I remember. We're gonna try and figure this out. Going back and doing some code archaeology. So I remember let me mute my speakers. So we did like a create, right? So we had a single border window handle, which we initialized as 0, which is like a null handle. And let's just go and see where we create that. So I guess we called create somewhere, which is right. So if we had the active window border option set to true, we would create the komorebi border window. And it was a bit of a mess, right? Because there's only one window, one border window, and we're moving it around and attaching it to different application windows. And the way that looked was pretty crazy. So in our process command handler, where we handle all of the komorebi C commands, which are called via hotkeys, we'd say, okay, if it's any of these messages and we don't have any visible windows, let's try and hide it, right? Because you don't want a border on an empty workspace. Makes sense. And then after all of those messages had been handled, we'd handle them all again. And if it was any one of these messages, resize, move, toggle, float, monocle, promote, any of these, we would do some stuff and figure out what the color of the border should be, right? Because you can have different colors for monocle mode, for stacks, all of that stuff. And then finally, we would set the border. But if we toggled pause, we would hide the border, or if we were no longer paused, we would bring the border back. And I think hopefully you can see where this is going. There's a lot of mixing of concerns, right? The process command handler ideally should just be processing commands, right? Like it shouldn't have to deal with all of these edge cases in the command handler. And then that wasn't the worst of it, because if you go over to process event, if we have the border enabled, and this is right at the start of the process handler, we're doing a whole bunch of stuff. We got stack bar. Oh my god, the stack bar was still... we didn't have the border manager or the stack bar manager at this point. It was all a mess. And so, we go through our main event handler, and we handle events like focus, change, show, all of these. And then you come here, and if we're not on tiling workspace, we hide the border. We're doing this in process event, which is insane. I'm not sure why I ever did this, but it was like this for a time. And then, okay, if we are tiling on the workspace and the border is enabled, we match a whole subset of events again. So if we have just started resizing, then we hide the border. If we are doing any of the event handling for these events, show, focus, change, all of these, then we're doing a lot of stuff, right? Basically what I'm saying is we have a single HWND, a single border, and we're just moving it around, right? So we're only ever tracking the state for one HWND, and that was a problem, right? You can't have multiple border windows when you have like an architecture like this. Like how would you make that work? You can't make that work. So let us fast forward to version 0.1.26. Let's just do a quick git checkout. If you have a look here, you see we have the border manager and we have stack bar we have a whole bunch of isolated modules that are just doing things where they're doing things that depend on changes to the state that happen in process event and process command. But we don't want to handle those changes inside of these processes for commands and events because they're pretty complex, and it would be nice to handle them separately once all of the state changes have been confirmed, right? Instead of trying to figure out what to do while the state is changing, I thought, why don't we just let the state settle, send a notification to the border manager, to the stack bar manager, and then based on whatever the state is, we can draw borders, we can draw stack bar tabs, we can do all of that stuff. So let's close out. Actually, we're not going to close these out yet. We're going to look at how that works in practice, right? So let me find our notification. Right, so after we have processed the event, we create a notification and then we send that to the subscribers, but also we send this empty notification. This is just pub struct notification. It's a dummy struct. But we send that notification over to the border manager. And this is happening pretty much right at the end of the function, of the process event function. And there is something similar for process command. Let me find that notification. Here. It's like process command right at the end. We're sending border manager one of these empty notifications. And it's just saying, hey, you know what? We have done a whole bunch of changes to the state. Or maybe we haven't changed the state, but we've gone through a cycle of process command or process event where the state might have changed. So do something, border manager, so that the borders look right? So let's head on over here into the border manager module. We have now in the border manager module all of the stuff we need related to borders, right? So we have the border width offset, whether it's enabled or not as an atomic bool. And these all need to be atomic because we're working across threads, or we're sharing state across threads. And we have our notification, we have some channels. And if we come over to listen to notifications, which is where we start the border manager in the main function, border manager, listen for notifications, this starts a thread. And in this thread, we loop over handle notifications. And so if this errors out, we will just start trying to handle more notifications. It'll restart the thread. So we come over into handle notifications, we get our notification receiver, and every time we receive a notification, we do stuff. And that stuff is what tells us, that, okay, this window on the left, this is the focused window, so it gets the focused border. These two are unfocused, so they'll get unfocused borders. And when I stack, this is what is going to go through and check the container here. Hey, do I have more than one window? Okay, so you're going to get the stack color, right? And that's everything that is going on in here. And this is happening for every single event that is sent from process command or process event, for every single notification being sent from there. And so let's have a look at what this is doing. So if the last event that we processed was within the last 50 milliseconds, we continue. This is like a little trick to avoid the spammy nature of some of the notifications that come, especially from process event. Because, for example, when you're doing, even when I'm like going up and down like this on IntelliJ, it's sending a whole bunch of object name change notifications. So you don't really want this to be using up CPU cycles, spamming, using up CPU cycles from the spamming that IntelliJ is doing. So, okay, we check that, it's not within the last 50 millis, then we update the instant and we continue. We get a lock on the border state and border monitors. Now, these are hash maps. These are global hash maps here. And because they are global hash maps, in Rust you need to wrap these in a mutex. We're not sharing them across threads, so we don't need to have an atomic reference counter, but we do need a mutex to be able to mutate them. And a mutex is kind of an expensive thing. We'll get into that a little bit later. So we get the locks on the border state and the border monitors, and then we check the window manager state. We have to take a lock on that because it's also in a mutex. And if borders are not enabled, or if the state of the window manager is paused, or if we're handling an alt tab across workspaces, then we destroy all of the borders, we clear our borders hash map, and then we try and listen for the next notification, because then maybe it has been enabled, maybe it has been unpaused, right? So we would do that. Otherwise, if we don't match any of these conditions, we take a look at the focused monitor. So we get the index, and we only want to operate on the focused workspace of each monitor, and we ignore workspaces that are that have tiling disabled. So they're not going to have borders. So we just go in our border map and we just destroy everything, right? Because we're on a workspace now where we don't expect to have any borders because tiling is disabled. We go through, we continue, and then we handle the monocle container separately. You know, we go through, we do the thing, we say, okay, if the monitor index is the focused monitor index, give this a monocle color, otherwise give it an unfocused color, because you could have two monocle containers, right, on two different monitors, and you only want the focused monitor to have the colored border. So, you know, we keep on going, if we are maximized, we don't want any borders on top of maximized windows, so we go through, destroy all of those. We destroy any borders not associated with a focused workspace, right? Because if you switch workspaces, you don't want the borders that are tracking the windows on other workspaces to still be visible on your new workspace. That wouldn't make any sense. And you'd have borders drawn all over here, and like it would not be good, right? So we kill all of those borders, we remove them, and then finally we get to our main loop, which is here. So for all of the containers on our focused workspace, we do a little something here, which is what enables dragging, right? So if we are dragging, just continue updating the border, and once we get past that, we get our border entry from our state map. We create one if one doesn't exist, otherwise we get the entry, and then we say that this border is associated with this monitor index, and depending on whether or not the focused window, depending on whether or not the container that we are operating on here, C container, is the focused container. If it's not, we're gonna set the window border to unfocused. If it is the focused window and the number of windows in that stack is greater than 1, we're gonna give it the stack color. Otherwise, we're just gonna give it the single window color. And this is happening for every single container, and this is how we have multiple borders. So finally, we have all of that information, and we have stored all of that information. This one again is in a hash map, which is behind a mutex. And then we call update on that border. And what does update do? So we make some adjustments to the border to respect our border width and our border offset. We store the state again in another hash map, which you need to take a lock on because it is wrapped in a mutex. And we update the position of the border if it's required, right? We're trying to do a little optimization here. Don't redraw if the position hasn't changed. But we do need to invalidate the border so that we can draw it with new colors, right? Because if we have changed the focus window, we need to do all the colors again. If we have windows that are now in a stack, we need to do all the colors again. And so once we call invalidate, this triggers this system callback. Specifically, it triggers the WM paint message, which needs to be handled. So what do we do here? Well, we get a lock on our rect state hash map, and then we try and get the rect that is associated with the border window handle, right? Because you get the window handle for the callback is on the specific window handle, right? So you get the window handle through, and hopefully we have something in there and you get the rect. Then we do another lock on the focus state hash map, again behind a mutex. And this is what tells us, you know, are we focused? Are we stack? Are we monocle? And if we don't get something, we just kind of default to unfocused. Then we do the actual drawing, right? So I don't want to get too much into this GDI stuff. You get a paint struct, you begin painting, you create a pen, you create a brush, you draw the border, and depending on the style that the user has set, you draw it rounded or you draw it square, then you end the paint. And that's like a whole cycle. So with that backstory, let's flip back over to GitHub issues. So bug, maybe a perf issue, high CPU and fan speed. This was initially reported by Kevin Nitro G, and then we got a little bit more information when Thomas Rood NL was able to share some concrete numbers here. So CPU usage is reported in the 25 to 50% range on idle. That is insane. You should never have that, right? Like komorebi should be -1 or less than 1%, generally. So this is already very concerning. And Thomas also said that I can reproduce it by launching komorebi and quickly switching between the first workspace and the empty second workspace. Doing this about 20-30 times already gets me in the 4 to 8% idle CPU usage on bottom, which is it's actually the most asked question I get about this. Everyone's like, what is this application here in the bottom left? The name of the application is Bottom by Clement Tsang. Anyway, now we have a little bit more information, but I still cannot reproduce this. Cannot reproduce this for the life of me. And so I start thinking, right? Another thing I noticed is that my active window borders disappear after some time, which may or may not be related to the issue. I had actually solved something here, right? I have all these open, so I noted that when I was creating pens and H brushes, solid brushes, I was not deleting them. And so this is one of the sharp edges of using the Windows crate in Rust. You're so used to Rust doing the right thing by default. The Windows crate does not do that. Like it is an unsafe crate. So this is like, you have to call free on the memory kind of delete object. Like you do it through the interface provided by the Win32 API. But I was like, that's interesting. Maybe something is going on with the border manager here. And then Starries also said, I'm having the same thing. I'm changing workspaces several times during the day, moving windows around between workspaces. So in this case, the user is not like rapidly switching between workspaces. They're just like doing their daily stuff. And so at this point, I'm thinking the only thing that has really changed when it comes to switching between workspaces, between the last release, 0.1.25, and the current release, 0.1.26, is that, we have this border manager and we're drawing more than a single border window. And we're actually destroying border windows quite a lot. We're creating and destroying because we're waiting until we receive a border manager notification once all of the state processing has happened in process event and process command. And then, we're just updating stuff. Sometimes if you have, 10 windows open on one workspace, and you switch to a workspace that has 1 or 2 windows open, you've got to go and you've got to destroy 8 border rects, 8 border windows, right? And similarly, if you're going from a workspace like this one, where you only have a single border, to a workspace that again has 8, 10, 12 windows open, you're going to have to create all of those border windows, those border rects. And I was like, okay, this seems like a reasonably sensible place to start the investigation for something that I'm not able to reproduce, right? So we got some feedback here saying I just tried to replicate it with the borders off and it seems like the issue does not reappear. CPU usage stays below 1%, both while switching workspaces and afterwards. So, okay, we're in the right area, right? Now, we had a lot of things to improve in terms of performance in the border manager, and in the next release, hopefully you'll feel it. Your computers will feel it. So I'm going to go through some of the changes that I was making and some of the rationale behind that. So this was the change where I added the delete objects for HPen and HBrush. This stops the border windows disappearing randomly after, komorebi has been running for a certain time. And all right, so the first thing that I did was to introduce bounded channels. So we're using channels to pass messages. And I was like, you know what? I'm sure that leaving channels unbounded is not great. And I actually rust bounded channels unbounded. I think it was Burnt Sushi who I saw write this. No. Was it this one? Maybe it wasn't Burnt Sushi. But basically, I saw a... Wait, now it's gonna bug me if I don't find it. I'm not gonna find it, am I? I should have had it saved. No, that's not it. Basically, I read something that said it's a bad idea to have unbounded channels when you don't really have control of what is getting sent over those channels. And we don't have control over the events that we're getting from the system, so it's very easy for the channels to balloon up. But also you can apply back pressure if you have bounded channels. So we did some of that, and we added bounded channels everywhere. This didn't do much, but it did significantly reduce memory usage, because we were up to like 60 megs, I remember, in version 0.1.26. Sometimes I saw 80 megabytes of memory usage, and I think now, I saw somebody in the Discord channel, they posted, hey, I've got 4 megabytes of memory usage now after we introduced bounded channels. So that was a nice little thing. That was a nice little bit of performance optimization. However, this did not address the issue that people were facing here. So that was one. And then the next thing was, I was like, you know what? We have so many mutexes, and getting locks on mutexes can be expensive, especially when you're repeatedly trying to get those locks. And this happens a lot, when you're switching workspaces, right? Because every time we go through the border manager notification handler loop, we're getting all of these locks, and then we send the invalidate message and we're getting these locks again. I was like, all right, let's reduce some of these mutexes, right? Where are some places where we don't necessarily need to use a mutex? So Here I managed to change 2 of these. So I had arc mutex z order, arc mutex border style. I replaced these with atomic cell from the crossbeam library, I believe it is. Yeah, and I did some testing on this. Atomic cell. Oh my gosh, what happened there? Atomic cell crossbeam. There is a method on this where you can call is lock free, and so I checked, and these were both lock free because z order is an enum. It's just like a basic enum, so is border style. So that was great. And then I also managed to remove the rect state mutex hash map. And so if you'll recall, what this was doing was for the window handle of the border, it was storing the updated rect position. And we have to do this, unfortunately, because... where is this now? Yeah, we have to do this because while we change the rect in update, so we're passing the rect through to update, we don't actually get to call the callback directly, right? That just kind of gets called for us whenever we send the invalidate rect API call. And so, like, we're not able to pass anything through here, which is why I was like, okay, I need to pull that state from somewhere. Let me put it in a hash map. It turned out that it was possible to replace this with a call to the Windows API, so window rect for window, because we already set the border position, right? We set the border position here, so this updated rect, when we query the Windows API, that is what we are going to get back. So I was like, cool, you know, we're making some progress. We're removing mutexes in the hot path. You know, that's pretty good. That's pretty good. Unfortunately, this also did not make much of a difference. And I was like, okay, that's not great. And so we had some feedback here. I'm testing the latest artifact with borders on. After a couple of hours, the system started to be sluggish and the CPU usage went up to 13-14%. So the CPU usage had lowered, right? Like, we're not talking 50%, you know, like we were before, but it's like, this is still unacceptable. CPU usage for komorebi should generally be less than 1%, especially when idle. It's like, it's crazy. Should not be this high. So, you know, we continue doing stuff. We reduce the mutex usage in the hot path. And then I thought, you know what, instead of trying to reduce mutex usage, because like the only other one that I could have removed, no, the only other use of a mutex was one that I couldn't remove. I was like, okay, how about we try doing less work, right? Instead of trying to optimize the hot path, why don't we try and exit out of the hot path as early as possible? So I had to implement partial EQ in a bunch of places for this to work. But we head on over to the border manager. Maybe we should split this one. And let's see. So even before we get these locks, right? So we're trying to reduce the number of locks that we get. So let's do some processing before we have to get the locks on these mutexes and see if we can just avoid, right? Like, if we can avoid, we're going to be better off. So we start off with a snapshot, which is an empty ring. and then we grab the monitor state and we store it in this latest snapshot variable. And this is outside of the notification loop, right? So this is every notification we're receiving. And what we're going to do is we are going to compare and say, if the two snapshots are the same, we don't actually need to do anything, because we only need to update the borders if something has changed, right? So like if I send this message, which moves my focus to the right, my focused index in my ring of containers has changed, and I need to do an update to all of the borders, or just the borders that need the update. But in order to go forward, I need to get the locks, and I need to go through all of that processing. So I was like, okay, at the trade-off, at a little bit of a memory trade-off, we can do this comparison between the snapshots and decide, hey, if we haven't changed anything that matters to us in the border manager, let's just not even go through all of this, because we're just wasting CPU cycles. So that was my clever little idea. Unfortunately, this also did not solve the root problem, but we did get some nice performance gains out of this. There were a couple of edge cases here when I realized. So in just doing the basic snapshot, we broke the dragability, we broke pausing and unpausing and retiling. So went through and fixed that. And this was the artifact that I got the feedback on, that this is not working. This is still not working, even though we have reduced the CPU usage in these idle spikes and peaks. It's still way too high. We got some people looking in Visual Studio, and this was actually my first time using Visual Studio to do some debugging as well. You know what? This is already a long video. Why not walk through how we did that? And this is actually how I identified the hot path. I've never used Visual Studio before this, so you come over to debug, you attach to process, and you filter your process. You come in here, you double click and attach, and then it's just looking at memory usage, it's looking at CPU usage, and there is a bit here. So we don't have the project in here, but you can hit break all, and it's going to take a look at the code that has been executed. And this works better if you have like the PDB file. I'm not running with the exe and the PDB file next to each other, but like you can go in and you can drill down and you can see what is taking up most of the CPU cycles. And this is how we found out that, we had a hunch that it was in the border manager, but this is how we found out for sure that it is the border manager. So if you do need to do this sort of debugging in the future, you can use Visual Studio Code. Plays pretty nicely with binaries of all sorts. So we got to this point. We're still not really having a lot of success. So I decided to just put everything that I knew at this point together, and we'll just go through this. This was 4 days ago, still pretty recent. Since this issue is getting quite long, here is a quick summary of what the investigation so far has shown. The core issue is not that drawing borders and changing workspaces consume CPU cycles, but that komorebi continues to consume CPU cycles at a growing rate over the lifetime of the process. There is no clear reproduction for this core issue. This only presents on the machines of some users, but not all users. The exact combination of conditions required for the core issue to present for the impacted subset of users still remains unknown. One of the conditions is that the borders should be enabled for the impacted subset of users. I don't think that this is related. I know it might be, but nobody using NVIDIA graphics cards who was active in this thread was able to reproduce this, although this was present on both Intel and AMD CPUs. Although we had significant performance improvements after all the code changes that we just walked through, the core issue, right? The core issue had still not been addressed. So the next steps that I laid out here, since the core issue only presents when borders are enabled, we should continue looking in the Border Manager module. Since we have aggressively optimized our own logic, the underlying issue is probably somewhere in the Win32 system calls that we're making. And then the system calls are in the update and callback functions. So update triggers invalidate rect, which triggers WM paint, which we just walked through, and we have some code here. And so this is where, I mean, this was frustrating the whole time, but this is where it got particularly frustrating. So this is not documented in the WM paint docs or the invalidate rect docs, but I found this on an old Stack Overflow comment. They say Windows generates the WM paint message when your Windows update region is not empty. What you are supposed to do is mark it as empty again. You do so, for example, by calling begin or end paint. If you don't, then Windows immediately generates yet another WM paint message, still trying to get the update region emptied. Your thread will burn 100% core, idly processing WM paint messages and not actually getting the job done. Maybe you are actually painting, Windows just doesn't know what you painted and doesn't try to guess at it. Using begin/end paint is very much the sane way to get that job done. So if you look at our code in WM paint, we are not always calling begin and end paint, right? We do if let OK because window rect returns a result. So if this, for whatever reason, if this call fails, then we're never going to call begin paint or end paint. How would I know this if I hadn't found this Stack Overflow comment randomly? Because it's not in the docs. It is not in the docs. But that got me thinking, right? I was like, you know what, we should probably, there's no reason why we can't lift the paint struct and the HDC and the HPen out of here. My thinking in doing it like this was like, hey, we don't want to allocate if we don't have work to do. Like that was my naive. I don't even think it's naive. I think it's rational thinking. Don't allocate unless you're going to do work. I don't think that's a crazy way to approach something like this. But apparently, in order to validate the rect that has been invalidated, this has to be called. There's some magic juju going on beneath the scenes. Yeah, and so we are coming to the end of the story now. And that was, it seems like after making this change, where are we? This commit pushes up the calls to begin and end paint into the border callback function to ensure that the client area of the border rect is always validated after calls to invalidate rect from the update function. The callback also logs errors whenever it is not possible to get the border rect to operate on for any reason. And apparently the validate rect call does nothing if you have already called begin and end paint, so I got rid of that. And why don't we do this in split mode? So you can see right at the beginning now of WM paint, we have our paint struct and we call begin paint. We changed the if let OK to a match. So if we get the rect, then we do the stuff. And if we are not able to, then we log an error. So my thinking, I'm not able to validate this without access to other people's computers. My thinking is that for people who were seeing this elevated CPU usage, they were triggering the error path, right? And so if the error path is triggered here, we don't do anything. We return L result with 0. But now, even if the error path is triggered, we're doing the allocation here, begin paint and end paint. Yeah, really, really frustrating and pretty stupid, in my opinion. And so once I'd made these changes, I thought, hey, we can validate this. We can add some more validation to this to make sure that we are only triggering this code path when where is that code path? We're only triggering this code path where we handle WM paint if the window kind has changed. So what does that look like? Maybe we go here. So the update function now takes a should invalidate boolean. And let's say that this is a false. Should update is false. Should invalidate rather is false. If it's false, then we won't call invalidate, which means we won't go through handling WM paint. That makes sense, right? If you have nothing to update in terms of the color of the border, just don't even trigger this code path. Do less work, right? Less work equals less CPU cycles. But even if there is no color change, but there is a position change, then, should invalidate, do the thing. And we're able to do that by checking the last focus state, which is here, right? So when we were updating the focus state before, we were doing nothing because insert, if there is something in the key in a hash map that you're inserting into, this actually has a return type, which is an option of whatever was in there before, whatever we replaced. So now we would take the last focus state and compare it to the new focus state. And so if those two are different, then we should invalidate. Or if there was nothing to compare against, then we should invalidate and trigger that expensive code path. And then the last change that I made was just increasing the bounds, because there were some people who were getting crashes because the bounds were too low. Oh my god, that took me 2 freaking weeks of thinking and iterating and just waiting for feedback. And let's just say I'm glad that it's nearing a conclusion. So Starries was saying that the situation looks much better. We have small CPU spikes when we are doing the deliberate reproduction of spamming workspace changes, which is expected, but also it's nothing dramatic because we've made all of those performance improvements and idle CPU usage seems to be under control, and also we notice less memory utilization overall. So, in trying to track down this performance issue that I personally was not able to reproduce, that others were also not able to reproduce. We ended up improving things for a whole bunch of people. Q0 also chimed in saying, hey, everything is very stable. I haven't had any border window breaks. The review is positive. Thomas has not been able to run this yet, but it's looking positive. And Kevin Nitro G provided some initial feedback that the commit is fine, but wait, let us test a bit more. So I'm going to hold on until I hear back from Thomas Rude. And hopefully we are going to get this out in version 0.1.27. Oh my gosh, 50 minutes. What a long video. Much shorter, however, than the amount of time that I spent trying to get my head around this and all the different things that I tried. So hopefully this was interesting. If you are ever in a position where you have especially a performance-related issue or a regression that you yourself as a software developer, as a software maintainer, are not able to reproduce, hopefully this will give you some ideas about how to approach that. Oh, I am exhausted now just walking through it because it's like it's a maze, it's a spider web. It is insane, but that is what you got to do sometimes to fix these esoteric issues. And my number one takeaway now is if I have performance issues again, instead of starting and trying to optimize the logic on whatever it is on like my application level in Komorebi, my first point of investigation in the future will be looking at the Win32 API system calls, and specifically looking for undocumented behavior that somehow we're just supposed to know. Alright, it has been a minute since we said thank you to the sponsors. Where is the sponsor page? Here it is. If you would like to sponsor, this is where you click. You get sent to the sponsor page, and we are going to say thank you to all of the lovely sponsors of this project. Thank you. Oh, look who it is. It is Thomas Rude. Thank you to Thomas Rude for being a sponsor and for being a great contributor. And you know what? I really do think that if you are spending the time to provide detailed feedback in issues, like in my book, you're considered a contributor. So thank you to Thomas. Thank you to Timothy, private sponsor number 1, Azine, James, Pavel, EFL1P, private sponsor number 2, Hamfelt, private sponsor number 3. We got a lot of private sponsors this time around. And Friday, Amr, thank you. Bo, thank you. Nia, Sundance, PJHFGGIJ, Hyro, DM1681, Darian, Kwang, Surefire, Solomon, private sponsor number 4, is it? Kilroy, my boy, Evan, Alex, and Hisayugi. Thank you all so very much, my friends. If you too would like to become a sponsor, come on over to the sponsor page. You can be a one-time sponsor, you can be a monthly sponsor. Honestly, even $1 a month, it makes a very big difference to me. But you know what? If you feel like you get $5 worth of $5 worth of what? Of less frustration in interacting with your Windows machine, feel free to sponsor $5 a month. I would appreciate that. If however you are not in a position to become a sponsor, the very next best thing that you can do is head on over. Actually, you don't need to head on over because you're watching this video. Just make sure that you hit subscribe while you are here on YouTube. It helps us out a little. We are a fully monetized YouTube channel as of February 2024 this year. And you know what? All of the time that you spend liking, interacting, commenting, watching little bits of ads before you skip them, it all helps the channel. We get some ad revenue, and it's a nice, simple, easy, passive way for you to support Komorebi. Alright, my friends. It was fun getting back to do another video, another long video. If you made it all the way here, congratulations. You are one of the few, one of the faithful. Alright, it is Eid today, by the way, so Eid Mubarak to those of you who celebrate. And with that, my friends, I hope that whatever you will do today, you have a great day. Free Palestine, and I'll see you all back here next time.